Good morning, students. This is Latif sir. Today I am going to discuss about the chapter 6th of class 11th chemistry. The topic is thermodynamics. Thermodynamics. This is a branch of chemistry which deal with the with different types of energies. Okay. So before starting discussion in details, first you have to know some important terms and their definitions. So first term is system. What is system? System, it refers to the portion of universe which is under observations. First term is system. It is what is system? It refers to the portion of universe which is under observation. Second term, is surroundings. Surrounding, it is the everything else in the universe except system is called surroundings, and the universe is formed by combination of system and surroundings. Suppose you have taken water in a beaker. See in this example, so water, you have taken some water in a beaker for observation or analysis, then the water, only water is known as system, and except water all the remaining part of the whole universe is known as surroundings. Okay, only the water in the beaker is known as system. Suppose you have taken some chemical compounds in a test tube, then the chemical compound in this test tube is known as system, and outside of this test tube all the or other parts of the whole universe is known as surroundings. Okay, and system surroundings are separated from system by some boundary. These are called boundary. Okay, surroundings are separated from system by boundary, real or imaginary boundaries. Okay, now see some now see types of system. Open system. First, open system, closed system and isolated system. Three types of system: open system, closed system and isolated system. So first, open system. What is open system? Open system, in a system when there is exchange of both energy and matter take place with the surroundings, then it is called open system. If there is exchange of energy, that is heat, and matter, that is mass, taking place with the surroundings, then it is called open system. For example, presence of reactants in an open beaker is an example of open system, or a cup of warm tea is an example of open system. Now closed system. Closed system, it is a system a system is said to be closed system when there is no exchange of mass or matter, no exchange of mass, as the system is closed. So in closed system, no exchange of mass or matter, but exchange of energy possible. Exchange of energy take place, but exchange of there is no exchange of matter or mass with the surroundings in case of closed system. For example of closed system, presence of reactant in a closed vessel. As the vessel is closed, there is no exchange of mass or matter with the surroundings, but there is an exchange of energy, heat, with the surroundings. Now see isolated system. Isolated system are those system in which there is no exchange of heat or energy or mass or matter. Okay, so in a system when no exchange of energy, no exchange of energy, that is heat, or matter takes place, no exchange of heat, no exchange of matter take place with the surroundings, then the system is called isolated system. Okay, so systems are three types: open, closed and isolated. open, closed, and isolated. In open system, both exchange of both energy and matter take place. In closed system, exchange of matter take place, or exchange of mass or exchange of substances take place, but exchange of energy or heat not take. There is no exchange of heat or energy. With this no, in case of closed system, exchange of energy take place, but there is no exchange of matter or mass. And in case of isolated system, there is no exchange of heat or no exchange of matter. Okay, for example of isolated system, presence of reactant in thermoflux. Suppose you have taken some water in a thermoflux, then the water in thermoflux, then the hot water in the thermoflux is known as isolated system. So the presence of reactant in thermoflux or substances in an isolated insulated means there is no exchange of heat, or there is no exchange of heat and there is no exchange of matter. Okay, so insulated closed vessel is an example of isolated system. So types of system, three types: open, closed, and insulated. Okay, graphically from this picture you can understand about closed system, open system, and isolated system. Okay, now two more types of system: homogeneous system and heterogeneous system. Homogeneous system: a system is said to be homogeneous when all the constituent present in the same phase and is uniform throughout the system. When homogeneous system, a system is said to be homogeneous when all the constituent present in the same phase, all the constituents are present in gaseous, either gaseous state or in solid state or in liquid state. Okay, so a system is said to be homogeneous when all the constituent present in the same phase and is uniform throughout the system. For example, mixture of two miscible liquid is an example of homogeneous system. Second, heterogeneous system. Heterogeneous system, it is a mixture. Heterogeneous system, it is a mixture is said to be heterogeneous when it is consist of two or more phases. A mixture is said to be heterogeneous when it is when it consists of two or more phases and the composition is not uniform. For example, mixture of insoluble solid in water is an example of heterogeneous system. Okay, now state function or state of a system. State of a system, the state of a thermodynamic system means its microscopic or macroscopic properties. Macroscopic properties means the pressure of the system, volume of the system, temperature of the system, that is measurable properties. Okay, state of a system is determined by some measurable properties or which are also called macroscopic properties or bulk properties, which are pressure, volume, temperature, amount of substance, which is expressed as mole number n. Okay, and these are also called state function because these properties describe the properties or nature of the system. Now see, another type of process is isothermal. Now type of change in a system. First one is isothermal process. Now I am going to discuss about different types of processes. First I have told what is system, what is surroundings, example of system, example of surroundings, and then types of system: open, closed, and isolated. And another types of system is homogeneous and heterogeneous. Now see types of processes change. First one is isothermal process. Iso means same, thermal means temperature. So same temperature remain constant. Delta T temperature is delta T is equal to 0 in these processes. So when the operation is carried out at constant temperature, then the process is said to be isothermal. At constant temperature, okay, when the process is carried out at constant temperature, then the process is said to be isothermal. For example, for isothermal process, you have to remember that delta T or dt is equal to 0. That means change in temperature is equal to 0. This is because temperature remain constant. Initial and final temperature remain constant. Okay, remain same. That's why delta T, that is change in temperature, is equal to 0. Next type of process is adiabatic process. First process I have told isothermal process. Next, adiabatic process. It is a process in which there is no transfer of heat between system and surroundings. No transfer of heat, that is no change in uh, no exchange of heat with the surroundings. Okay, so adiabatic process or adiabatic changes are those change or process in which there is no transfer or exchange of heat between system and surroundings. So Q is equal to 0. Next, isobaric pressure process. Iso means same, baric means pressure. Isobaric. Isobaric, same pressure. Pressure remain constant. So when the process is carried out at constant pressure, when the process is carried out at constant pressure, that is delta P is equal to 0. Initial and final pressure remain same. That's why delta P is equal to 0 or delta P is equal to 0. So when the process is carried out at constant pressure, it is said to be isobaric process. Okay. Example of isobaric process: boiling of water, freezing of ice. All these processes are isobaric at constant pressure, and the constant pressure is 1 atm. You know that. Now isochoric process. Iso means same, choric means volume. Isochoric, volume constant. So isochoric process means a process when carried out at constant volume. Choric means volume constant, volume remains same, then it is known as isochoric process. So delta V is equal to 0 for isochoric process. Delta V or volume change is equal to 0. Okay, for isochoric process. Next type of process is cyclic process. I am discussing about different types of processes: isothermal, isobaric, isochoric, and then cyclic process. Cyclic process: if a system undergoes a series of changes and finally returns to the initial state, then it is said to be a cyclic process. If a system undergoes a series of changes and finally returns to the initial state, it is said to be cyclic process. For example, suppose conversion of liquid ice to liquid water, water to water vapor, and then again water vapor to liquid water to ice. This entire conversion, okay, is cyclic process. So if a system undergoes a series of changes and finally returns to the initial state, then it is said to be cyclic process. And now see reversible process. Reversible process: when when a process when in a process a change is brought in such a way that the process could at any moment or any step be reversed by an infinitesimal change in external conditions, then the process is known as reversible. One more definition of reversible process given here. You can see reversible process is a process that follows the reversible path. You can reverse the process by changing external pressure, temperature, volume. Okay, so reversible process is a process that follows the reversible path, that is a process which occur at infinite number of steps in this way that the equilibrium conditions are maintained at each step, and the process can be reversed by infinitesimal change in the state function, that is change in temperature, pressure, volume. So reversible process is a process that follows the reversible path, and the process which occur in infinite number of steps in this way that the equilibrium conditions are maintained at each step, and the process can be reversed by infinitesimal change in the state function. An irreversible process, those process you cannot reverse this process. So the process which cannot be reversed, an amount of energy increases, are called reversible process, and irreversible process are very slow process. Reversible process are very slow process, while irreversible process are very fast one step process. Reversible process take place in large number of steps, uh, while irreversible process generally take place in one step. And all naturally occurring processes are irreversible process. So reversible and irreversible. Reversible process, you can reverse the reversible processes, and irreversible processes cannot be reversed by changing external conditions. Now see internal energy. Internal energy, it is a state function. So what is the internal energy? Internal energy which is represented by capital E or capital U. Okay, capital U, generally it is represented by capital U. It is the total energy within the substance, and it is the sum of many steps of energies like vibrational energy, translational energy, okay, etc. Translational, vibrational, rotational, kinetic, all types of sum of all types of energies is known as internal energy. It is the stored energy within a substance. Okay, and it is a extensive property. Extensive means mass dependent property. Amount, it is depend on the amount of substance. Okay, larger the value of amount of substance, higher is the value of internal energy, and it is also a state function. These are properties of internal energy. Okay, so internal energy is the total stored energy within a substance, and it is due to the sum of different types of energies like kinetic energy, translational energy, vibrational energy, rotational energy. Okay, and internal energy, it is a extensive property, that is mass dependent property or amount of substance dependent property, and it is a state function. It depends on initial and final state of the system. Now change in internal energy, you can change that internal energy by doing work or by transfer of heat. Okay, you can change the value of internal energy by doing work or by transfer of heat. Okay, so and the change in internal energy is represented like this. Suppose internal energy of initial state is uv and internal energy of final state is ua. uh, Internal energy of initial state is ua, and internal energy of final step or final state is ub. Then change in internal energy delta u is equal to ub minus ua, or delta u is equal to u2. Delta u means change in internal energy is equal to u2 minus u1. This is the change in internal energy. Okay, and now change in internal energy by transfer of heat. Internal energy of a system can be changed by transfer of heat, I have told, or by doing work. Okay, by transfer of heat from the surroundings to the system without doing work, you can also change the internal energy of the system. And if the work is if you are not doing any work on the system, then the value of internal energy is equal to heat supplied to the system, that is delta u is equal to q. which is also written as delta U is equal to QV. If there is no work, done on the system, then change in internal energy is equal to heat supplied on the system. Delta U is equal to Q. Now see first law of thermodynamics. First law of thermodynamics, most important law. And the first law of thermodynamics is actually is the law of conservation of energy. Law of conservation of energy. Okay, and the statement of first law of energy thermodynamics is energy can neither be created nor destroyed. Energy can neither be created nor destroyed, although it can be converted from one form to another. Energy can neither be created nor destroyed, although it can be converted from one form to another form. And mathematically, the mathematical expression of first law of thermodynamics is equal to is delta U is equal to Q plus W. Suppose internal energy of a system, initial internal energy is U1 and final internal energy is U2. Then change in internal energy delta U is equal to U2 minus U1, which is equal to, suppose you have supplied Q amount of heat to the system, then and you have also done W amount work on the system. Work is also one type of energy. So you have supplied Q amount energy heat to the system and you have done W amount work on the system, then total energy supplied to the system is equal to Q plus W, and change in internal energy is equal to Q plus W. This is the mathematical expression of thermodynamics. Okay, and here some sign conversion you have to remember. Q is positive if the system absorb heat, or if heat is supplied to the system, then Q is positive, while Q is negative if heat is lost by the system. Q is positive if heat is supplied to the system, and Q is negative if heat is lost by the system. And W is positive if work done on the system, and W is negative, work is negative if work done by the system. If the system do work, then the work done is negative, and if work is done on the system, then the value of W means work, is positive. Okay, so you have to remember the first law statement and the mathematical expression delta U is equal to Q plus W. Using this expression, mathematical expression of first law of thermodynamics, you have to solve some numerical problem. Okay, and you have to also know this sign convention, important, when Q is positive, when Q is negative, when W is positive, when W is negative. Okay, now some work energy in the first law of thermodynamics, you can see here W, Q plus W. So you have to calculate work. Suppose you have taken some amount of gas in a cylinder. Now you are changing the pressure, pressure of the system of the cylinder, then volume of the gas will be changed. Okay, you are changing the pressure, you are reducing the pressure on the piston of the cylinder, then the volume of the gas will be increased. Now on changing pressure, volume changes. Okay, if you reduce the pressure, then the volume will be increased. So the gas, there will be some work done on the system, you are reducing the pressure. Okay, so the gas is doing some work in this case. When you are reducing pressure on the gas taken in a cylinder, then the gas is doing some work, and mathematically it is calculated by using this equation. Work is minus pressure into volume change, pressure into delta V. W is equal to the mathematical expression of calculation of work, how much work done is calculated by using this equation. W is equal to minus external pressure into volume change. Okay, minus external pressure into volume change. So you have to remember some general expression of work done. the formula of work done. So work done in isothermal and reversible expansion of ideal gas. Suppose you have taken some ideal gas in a cylinder, n mole ideal gas, suppose you have taken in a cylinder, then you are reducing pressure on the gas, then you will see that gas is volume of gas increases, and you have to calculate work done. So work done W reversible, which is equal to minus nRT ln v final by v initial, that is final volume by initial volume. Or you can also write this equation, and you have to remember that W is equal to minus 2.303 nRT log V2 by V1. This is the final equation, and you have to remember this equation. Using this equation, you have to calculate some numerical problem, and this is for reversible isothermal reversible expansion of ideal gas. Isothermal means temperature remain constant. Okay, so if temperature remain constant, then delta U also is constant. Internal energy change is constant, because if temperature remain constant, internal energy change is also constant. Delta U is also constant. Okay, so the formula of calculation of work done in isothermal reversible expansion of ideal gas is W reversible is equal to minus 2.303 nRT log V final, or V2 by V initial, or V1. V2 by V1 or Vf by Vi, where n is the number of moles of gas, R is universal gas constant, and T is the temperature in absolute scale. Now see isothermal free expansion. Free expansion means external pressure is 0. So if external pressure is 0, I have told that work done means pressure minus pressure in external pressure into volume change. If external pressure is 0, then the work done, W is equal to minus P into delta V, P into delta V. If pressure, external pressure delta P is 0, then W is also 0, and process, as the process is isothermal, I have told that isothermal means temperature remain constant, and if temperature not change, then delta U, there is no change in internal energy. Okay, so when external in case of free expansion, external pressure is 0, so work done is also 0. You have to remember, in case of free expansion, isothermal free expansion of ideal gas into vacuum, W is equal to 0, because external pressure is 0. And now for irreversible process, and if the process is isothermal, I have told that according to first law of thermodynamics, delta U is equal to Q plus W, Q plus W, and as the process is isothermal, delta U is equal to 0, and as the process is isothermal, delta U is equal to 0, then Q is equal to W. Then what you can write? Then you can write Q is equal to minus W, Q is equal to minus W, as the process is isothermal, delta U is equal to 0, and W, you can calculate the work done in case of irreversible process. In case of irreversible process, the work done W is equal to external pressure into final volume minus initial volume. Okay, and for reversible process, W is equal to minus nRT ln V final by V initial, or 2.303 nRT log V final by V initial. Okay, you can use any one expression, and I have told this is isothermal process, that's why delta U is equal to 0. So Q is equal to minus W, okay, or W is equal to minus Q. So Q is also calculated by using this equation also. And for adiabatic process, Q is equal to 0, then the first law of thermodynamics becomes delta U is equal to Q plus W. So Q is 0, then W is equal to Q for adiabatic change. You have to remember this equation of calculation heat, energy, work done. Okay, and for isothermal process, you have to remember delta U is equal to 0. For adiabatic process, Q equal to 0. Then first law of thermodynamics looked like delta U is equal to Q. Okay, and in the next video, I'll discuss about enthalpy, internal energy, enthalpy, entropy gives free energy. Okay students, thank you.